Bismillahirrahmanirrahim. Assalamu alaikum. How are you, students? I am your chemistry teacher Faizullah Umar, and today we are going to study a new topic is intermolecular forces. Okay, first of all, let's define intermolecular forces. What is intermolecular force? Intermolecular forces are the forces that hold molecules together. Okay, they are between molecule and molecule, not inside the molecule. Okay, we have studied about the chemical bonding. Chemical bonding is also known as intramolecular force. You can see over here. Intramolecular force, it means chemical bonding. Okay, so what are the difference between chemical bonding and intermolecular forces? Intramolecular force or chemical bonding are the forces that hold atoms together within a molecule. They're inside the molecule, not outside of the molecule. But the intermolecular forces are the forces that exist between the molecule. Let me show you in the diagram. You can see that this one is a molecule of HCl, it's a molecule of HCl. The line you can see between them, this line, it is the polar chemical bonding, okay, polar bond. And you can see this one, this is the intermolecular force that is present between the hydrogen chloride and hydrogen chloride molecule. This is what? This is intermolecular force. So you can see that intermolecular forces are present between molecule and molecule, and intramolecular force, that's also known as chemical bonding, that is present inside the molecule. Okay, that's the thing that bonds atom with another atom to make a molecule. We have three types of intermolecular forces: dipole-dipole interactions, hydrogen bonding, and London dispersion forces. There are two types, two L's, like ion-ion interaction and ion-dipole interaction, but we are not studying it right now. I will just introduce it briefly at the end of this lesson. Okay, the first one is dipole-dipole interaction. Students, we have studied about the polar molecules. Okay, if it was a diatomic molecule, one polar bond can make a molecule polar. Okay, so what happens between a polar and polar molecule? How they attract each other? They attract each other with the dipole-dipole interaction. Okay, so you can see that this is a polar molecule HCl. This is also a polar molecule HCl. This end has partially positive charge. This end has a partially negative charge. And you can see this end has partially this was partially positive. This end has partially negative charge, and this end partially negative charge. Now you can see this partially positive charge attracts the partially negative charge of the other one. So partially positive charge attracts the partially negative charge of the neighboring molecule. This kind of attraction is formed in a dipole-dipole interaction. This is the first kind of intermolecular forces. They are between molecule and molecule. The molecule must be polar to have dipole-dipole interaction. Let's go for the next one. Next one is the hydrogen bonding. Hydrogen bonding is formed when one hydrogen is covalently bonded with fluorine, oxygen, or nitrogen. These three are the most electronegative elements. Okay, we can write in a short form like FON, F-O-N. Okay, F-O-N, FON, fluorine, oxygen, and nitrogen. If hydrogen has a bond with these three of one, then in this case the hydrogen bond is formed within a molecule. Let me give an example. The example is like water molecule, hydrogen as a bonding with oxygen, and oxygen, two lone pairs over here, one lone pair, two lone pair. And let me tell you about another example. For example, in ammonia, hydrogen, and again hydrogen, there is a one lone pair. These two molecules will have hydrogen bonding, the hydrogen bond kind of intermolecular force between the molecule, between the individual molecules. Okay. So what about the next one? Next one is the London dispersion forces. London dispersion forces exist within a non-polar molecule. Okay, if the molecule is non-polar, they have a non-polar covalent bond between the atoms inside the molecule. In this case, London dispersion forces will be formed. Or we can also say that London dispersion forces are also formed in noble gases. Noble gases. Okay, now you can see this helium and helium. How this kind of force is formed, how London dispersion force is formed. We know that there must be a charge, opposite charge, to attract each other. So what happens over here, due to the electrons, we know that electrons are orbiting around the nucleus. So when they are orbiting, sometimes they get to one side, so they form an instantaneous dipole. Okay, instantaneous dipole will be formed for a very short period of time. So in this case, one instantaneous dipole is formed in the atom A, and again same thing happens with the atom B. In this case, this instantaneous dipole of the partially positive charge of the instantaneous dipole attracts the partially negative charge of the instantaneous dipole of the other atom. So that's how this attraction occurs, and it will be for a very short period of time, and again it will disappear. Okay, so this is the reason that there is a kind of attraction between nonpolar molecules or nonpolar atoms. The next example is within a hydrogen molecule. We know that hydrogen bond is a nonpolar bond. And again, due to the electrons, sometimes this happens. Then there comes an instantaneous polarity, like an instantaneous dipole. You can see this is a partially negative charge, this one is a partially positive charge. So same thing happens with this molecule. So when these charges are close to each other, they attract each other, and in this case what happens, London dispersion force is formed between them, but it will be very short, for a very short period of time. Again it will disappear. But the strength of London dispersion forces are due to the number of electrons in the atoms or nonpolar molecules as well. For example, you can see that fluorine has 9 electrons. If we say it fluorine molecule, it will have 18 electrons. Okay, its melting point is minus 220, its boiling point is minus 188, and it is in a gas state at normal temperature. The next one is chlorine. Chlorine molecule will have 34 electrons. Okay, so it will have a melting point of minus 102, boiling point minus 34, and it is in a physical state of gas. The third one is bromine molecule. Bromine has 70 electrons in a bromine molecule. Melting point is minus 7, boiling point is 59, and the physical state at room temperature is liquid. The last one is iodine. Iodine will have 53 electrons. So 53 times 53 makes 106. So iodine molecule will have 106 electrons. So these 106 electrons form a strong London dispersion force between them. That's the reason that iodine is found in a solid form, and you can see that its boiling point is 184 and its melting point is 114. Now you can see that as much as the electron increase in a molecule or in an atom, the London dispersion force will be stronger, because the more electrons, there will be more instantaneous dipole, the more strong London dispersion force. And students, remember that there are the two other types of intermolecular force. As I told you, that it's not actually between molecules. The first one is ion-ion interaction. It's between ion and ion, negative ion, positive ion, cation and anion. And the second one is ion-dipole interaction. For example, if we put sodium chloride, if we dissolve sodium chloride inside the water, Na and Cl inside the water, it will be attracted by the molecules of water. For example, sodium will be attracted by the negative end of the molecule of the water, okay, and this one will be attracted by the positive end of the molecule of water, partially positive. Okay, so this attraction between them will be known as ion-dipole interaction. Okay, students, how forces of attraction affect the properties of compounds? Let me show you a very simple example. In ionic compounds, there will be ion-ion interaction, and it has the highest melting and boiling point. The next one is covalent compounds containing hydrogen bonded with fluorine, oxygen, and nitrogen, or I have told you short form FON, F-O-N. Okay, so there is a hydrogen bond and the relative order of boiling and melting point. Then its turn comes after ionic compounds. The third one is polar covalent bond. In polar covalent bond, we know that dipole-dipole interaction is present, and according to the relative order of boiling and melting point, its number is the third. And the last one is in non-polar covalent bonding, there will be London dispersion force, and it will have a lowest relative order of boiling and melting point. Well, students, hope you have learned. Let me ask you some question. What attractive forces present between polar molecules? Let me answer you. Yes, dipole-dipole force or dipole-dipole interaction. What attractive force is developed between non-polar molecule? I forget to write none over here. It's a non-polar molecule. Non-polar molecule, yes, there is London dispersion force between them. And what happens when hydrogen is covalently bonded with nitrogen, oxygen, and fluorine? Then there comes hydrogen bonding between molecules of these molecules. Okay, students, well, hope you have learned today's lesson. It was very easy, and still, if you have any question, you can write in the comment section below. And don't forget to subscribe our channel and like our videos. See you next time. Goodbye.